You are standing on Earth. Not the idea of Earth, the real thing. Solid ground under your feet, air filling your lungs, a sky that feels endless when you look up, even though you know it isn't. You've seen oceans. Maybe not all of them, but enough to understand their size. Water stretching past the horizon. Waves moving with a rhythm that feels ancient. It feels big. It feels like everything. But it isn't. Because if you could rise straight up, faster and faster, past the clouds, past the thin blue line of the atmosphere, something strange would happen. The world would begin to shrink. Cities would blur into patterns. Countries would disappear entirely. The oceans, those endless oceans, would fold into a single shining surface. And then, suddenly, Earth would fit in your hand. A blue marble in blackness. And that's the first moment things break, because your entire life has happened on something that small. Now go further. The moon appears beside Earth. Not close, not even a little. The distance between Earth and the moon is about 384,000 kilometers. You could line up every country on Earth side by side in that gap, and there would still be space left over. It's not a neighbor, it's a distant companion. Keep moving. The sun comes into view. At first it looks manageable. Bright, yes. Large, yes. But still something you can comprehend. Then you compare it. The sun is so big that you could fit about 1.3 million Earths inside it. Not next to each other, inside it. Now the scale starts to hurt, and yet, even the sun is just one star among hundreds of billions in our galaxy. You feel it now, that quiet shift, that moment when big stops meaning anything. But here's where it becomes unsettling, because somewhere out there, orbiting a small, dim star far closer to us than most, is a planet called Proxima Centauri b. It is real. It is roughly the size of Earth, and it sits in a region where temperatures could allow liquid water to exist. That one detail changes everything. Because liquid water is not just water. It is the condition for life as we know it. But this planet is not like Earth. Its star is smaller, colder, and far more violent. It flares. It spits radiation. It floods its surroundings with energy that would tear apart life here. And yet, scientists are not dismissing it. They are leaning in, because if life exists there, it would not look like anything you've ever seen. Not plants, not animals, not even microbes as you understand them. Something else, something shaped by a world where day and night might not exist the way they do here, where one side of the planet always faces the star, locked in eternal daylight, while the other side freezes in endless night, a world split in two, fire on one side, ice on the other, and somewhere in between, a thin line where conditions might be just right, a narrow band of possibility. That is where the question lives, and once you see it, you can't unsee it, because now you're not just looking at the sky anymore, you're wondering what might be looking back. Start again from Earth, from your position, your city, your street. Everything feels stable here, predictable. The sun rises, the sun sets. Day becomes night, night becomes day. But Proxima Centauri b does not have that rhythm. It orbits its star, Proxima Centauri, at a distance of only about 7 million kilometers. That's incredibly close. For comparison, Earth sits about 150 million kilometers from the sun, 20 times closer. If you stood on Proxima Centauri b, its star would dominate the sky. It would not be a distant disk. It would feel near, heavy, constant. And because of that closeness, something important happens. The planet is likely tidally locked. That means one side always faces the star, always. No sunrise, no sunset, just endless day. The other side never sees the light at all, just darkness, permanent. Imagine living on a world where half of it burns and half of it freezes solid. On the day side, temperatures could rise high enough to boil oceans, if oceans exist there at all. On the night side, the cold could trap everything in ice, locking the surface into stillness. But between those extremes, there may be a narrow region, a twilight zone. Not metaphorically, physically, a ring around the planet where the star sits forever on the horizon. Not rising, not setting, just there. In that band, temperatures could be stable enough for liquid water. And where there is liquid water, there is possibility. But this is where it gets stranger, because Proxima Centauri is not like our sun. It is a red dwarf star, smaller, dimmer, but far more active in bursts. It releases powerful flares, sudden eruptions of energy that blast radiation into space. On Earth, our magnetic field protects us. It deflects harmful solar radiation, shielding the surface and allowing life to exist. But on Proxima Centauri b, that protection may not exist, or it may be weaker, which means the surface could be exposed to intense radiation on a regular basis. Now pause, because this is the moment where most people assume life cannot survive. Too hot, too cold, too violent, end of story. But science doesn't stop there, because life on Earth has already shown us something uncomfortable. It adapts. There are organisms on Earth, extremophiles, that live in conditions that would kill almost everything else. Bacteria that survive in boiling water. Microbes that endure radiation levels that would destroy human cells instantly. Life is not fragile in the way you think. It is stubborn. So if life exists on Proxima Centauri b, it would not try to be like Earth life. It would become something else entirely, something shaped by constant radiation, something that doesn't rely on a day-night cycle, something that may not even use sunlight in the same way plants do here. Imagine a form of life that lives beneath the surface, shielded by rock or ice, feeding on chemical energy instead of light. Or organisms that thrive in the twilight band, evolving to handle constant exposure to a star that never moves. No seasons, no shadows that shift across the sky. Just a fixed world. Now zoom out. Proxima Centauri itself is about 4.24 light-years away from Earth. That means the light you see from it tonight left that star over 4 years ago. 4 years. Traveling at the speed of light. Nothing moves faster. If you tried to go there with current human technology, it would take tens of thousands of years. Generations upon generations, living and dying inside a journey that never ends for them. And that's how far close really is in space. And yet, it is our nearest stellar neighbor. Now feel that. The closest star system beyond our own is so far away that your entire civilization would struggle to reach it. And in that system, there may be a world with conditions for life, not guaranteed, not confirmed, but possible. And here comes the gut punch. There are hundreds of billions of stars in our galaxy. If even a small fraction of them have planets, and an even smaller fraction of those have conditions suitable for life, then worlds like Proxima Centauri b are not rare. They are everywhere. Hidden, silent, waiting. You are standing on one small planet, orbiting one ordinary star, in a galaxy so large it takes light 100,000 years to cross it. And beyond that galaxy, there are trillions more, each one filled with stars, each star potentially surrounded by planets, each planet a question. Are we alone, or are we just early? Back to Earth, back to where you started. the ground beneath your feet feels different now. Smaller, not physically, but in meaning. Because you've seen the scale. You've followed the distance from your street to your planet, to your star, to another star, to a world that might hold life that does not resemble anything you know. And it changes something quiet inside you, because for most of human history, the night sky was just lights, points, stories drawn between them. But now you know better. Each point is a sun. Each sun could have worlds, and some of those worlds may not be empty. Proxima Centauri b is not special because we know there is life there. We don't. It is special because it forces a question into the open. If life can exist there, under different light, different radiation, different rules, then life is not a rare accident tied only to Earth. It is a pattern, a process, something the universe does. And if that is true, then the universe may not be silent at all. It may be full of life, not loud, not obvious, but present, scattered across distances so vast that communication becomes almost meaningless. Civilizations separated not by space alone, but by time. Because even if something is out there, the signals would take years, centuries, millennia to cross the void. You wouldn't hear them in real time. You would hear echoes, old messages, ghosts of voices that may no longer exist. And they would hear ours the same way, delayed, fading, a conversation stretched across eternity. But even without contact, the idea changes us, because it removes something, that quiet assumption that we are the center, that everything is built around us. It isn't. The universe does not care where you are standing. It does not pause for your questions. It does not explain itself. And yet, here you are, a conscious being on a small planet, orbiting an ordinary star, able to look out into the dark and ask what might exist beyond it. That is not small. That is extraordinary. Because even if life exists on Proxima Centauri b, even if it exists on millions of worlds, you are still part of that same universe, made from the same elements, following the same laws, connected, even across impossible distance. So when you look up tonight, the sky is no longer empty. It is crowded with stars, with planets, with possibilities. And somewhere out there, on a world where the star never rises and never sets, something may be alive, not like you, not even close, but alive. And it has no idea that you are here.